of s squared minus this. Okay, here, expected value of this. Okay, np all squared. You know, we got in np, right? Now we need to figure out this guy. Okay, to figure this guy out, recall that s squared, you know that? S squared is the same thing as this, right? That's going to be s squared, right? Now, we want to figure out this guy. Expected value, or if I introduce expectation now, it's going to be this. Right? Now, the variance of x now, which is this minus this, is going to be look at that. If I want to find the variance of x right now, I need to find this. I already know this and this. Because if you go directly, if you find this directly, it's going to be complicated. Okay? Now, the variance of s is expectation into x minus 1 plus np minus np squared, which is like this, right? Now I want to figure this guy out. So to figure this guy out, expectation into this is summation x into x minus 1. Okay, I want to use a binomial now. If I want to find the expected value of that, so I'm actually going to have you see that here? That is the binomial distribution formula. Okay, now if you take a look at this guy now. You see that? You know what I'm going to do now? Here. You know, the other time I actually defined this as n into n minus 1 factorial. No, I'm going to go forward because of this guy. Okay? So what I'm going to do, see, n factorial will be this. And x factorial will be this. Do you see that? I can go all the way. But why do I stop? Why do I stop here? So that this can cancel this out. Okay. Now, like I said, you can take the picture. And what we're going to be doing now is going to be mathematical. But if you don't understand, ask question. Does that make sense? Okay, now, expectation into x minus 1 equal, okay, summation, let's start from 0 into n, okay. I can just simply write summation for now, s into x minus 1, n into n minus 1, n minus 2 factorial, divided by n minus s factorial, then x factorial is going to be x into x minus 1, s minus 2 factorial, okay, p raised to power s, q raised to power n minus s. Okay, now this guy, cancel that guy. Okay, now you're actually going to see this is going to come out, right? Now, I'm actually going to introduce a dummy. You remember the other time, I introduced p and p raised to power minus 1. So right here, I'm going to introduce this and this that can cancel out. So what I'm this guy p squared, I'm going to bring it here, right? And I'm going to combine this and this. So here now, summation, I'm going to be left with this. Any question? I introduce this and this. They can cancel out. Because if I don't do that, this is just going to carry s. And don't forget, what do you have here? S minus 2. Okay, now we are back. So right here, okay, if you follow what I did the other time, okay, here, n minus 2 factorial. So this minus this is this guy. So n minus 2 minus x minus 2 factorial is this guy. S minus 2 factorial, p raised to power that, and q raised to power n minus 2 minus x minus 2. You're actually going to see this is going to be another binomial. Okay? That's going to be another binomial if you let n minus 2 to be k and x minus 2 to be m. Okay? You're just going to have n into n minus 1 p squared summation. So n minus 2, that will be k factorial divided by k minus m factorial, m factorial, p raised to power m, q raised to power k minus m. Okay, this guy is another binomial. Sum of that is going to be 1, right? So this is going to be n into n minus 1 p squared. Okay, now if that guy is there now. Okay, so right now, expectation into x minus 1 actually give n into n minus 1 p squared. Okay, then I can come here now, plug that in. Okay, so the variance of s, if you want to follow here now, you're going to plug in this, right? Plus, minus. So let us simplify. N squared p squared, right? 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 What is that? So that is how we prove the variance. Okay? So that is the variance of S.